All right, everyone. Right on time to kick off today's webinar. So, thank you, everyone, so much for joining and welcome to the webinar today, where we're going to be talking about 3D print farms for on-demand robot manufacturing. Right, and this is not just science fiction. This is something that's happening today in Australia and in Asia Pacific. So today we have over 300 people that have registered for the webinar. So I'm super excited to answer all your questions and provide you with a lot of value of what's happening in the manufacturing industry. So my name is Richard Elving. I'm the director for Markforged in Asia Pacific South. This is what the agenda looks for us today. So we have Jason Hampton-Taylor, who's the director of Haddington Dynamics, with me on the call today, and Anthony Rosengren, who's the applications engineer at Markforged in Australia. And we will, after they do their presentations around robotics industry, we will then look at some real customer examples and how you can get real value right now. And then we also have time for a Q&A session, so you can ask your questions live by typing the questions in through Zoom here. You can type any questions that you have. So, first off, why are we on this call, right? So why is today's call important? Well, 3D printing and robotics is changing the way that we not only design and make things as manufacturers, right? And as you can see, what we're touching today is just the tip of the iceberg. But here are some great examples of 3D printing and robots growing rapidly. So we're seeing 23% growth year over year on average, right? And this trend will continue to grow into the mid-20s and, obviously continue. So why is this important for you as a manufacturer? Well, there's some obvious benefits by using robotics and using 3D printing for your business, such as improved speed to market, reduced downtime, and greater yields, right? So this is truly, truly important for you as a manufacturer. So with robotics and 3D printing comes the opportunity to basically transform your entire business. So things like lower production costs to improve the ability to compete. Machinist talent can focus on high value jobs, greater profit margins like every manufacturer want, right? Go to market faster by decreasing product development cycle times, or increasing the agility of your manufacturing operations by changing lines over faster. And of course, reduce money spent on physical inventory by transitioning to a digital inventory model. So by doing this type of transition, what does that mean for you as a manufacturer? Well, imagine a near future where your inventory moves from physical to digital, where your production costs go from high to low, where manufacturers are offshoring, right? Where we're now seeing a reshoring of manufacturing to local, or the logistics, rather than having the global logistics chain, basically things are just printed locally and made, close to the customer. And developing new products are no longer slow; they happen fast. And demand planning from design to managing your production goes from uncertain to predictable. So this is why we are on the call today. So I am going to hand over to the first speaker of today, which is Jason Hampton-Taylor. So while he gets his screen and starts sharing that, I'm going to do a brief introduction of Jason. So Jason operates as the International Director of Sales and Marketing at Haddington Dynamics. So he recently moved from Brisbane in Australia to Las Vegas and spending a lot of time there at the moment. He's got over 25 years experience from the industry within the CAD, BIM, and 3D scanning and additive manufacturing. So really happy to have you on the call, Jason. Thank you so much for joining, and look forward to hearing your story and Haddington Dynamics story.
Right. Thanks, Richard. Thanks a lot. And and welcome to the webinar today. Now, firstly, what I'd love to do is to thank Markforged, firstly, for organising this webinar, but also for their support of us as a company. In fact, I probably wouldn't be at Haddington Dynamics if it wasn't for Markforged. So I'll tell a little bit about that story in a moment. But yeah, firstly, and also I'd like to give good thanks to Richard Elving. He's been a massive supporter of me personally and of Haddington Dynamics as well. So firstly, we're going to be talking about something which is I've been evangelizing as I've been in the industry for many years, and that's something very close to my heart, the idea of creating mid to low volume manufactured items via a 3D print farm. And it was many years of me talking about this and organizing it before I actually came across Haddington Dynamics, who are actually doing this. So we tend to hear a lot about the Industry 4.0 playlist, and people are talking about it and integrating parts of that into their manufacturing systems. This is Haddington Dynamics is about as close as you get to really implementing those Industry 4.0 variable manufacturing process. So yeah, listen, Richard did do a little intro on me, and I won't labour this, but here is a bit of information on me. I've been associated with the Markforged brand actually in Australia since 2015. I initiated one of the first dealerships over there. Previously working with selling SolidWorks and Autodesk products. And as I mentioned, I actually discovered the Haddington Dynamics brand via the case study that Markforged kindly produced. It became part of what I was talking when I was talking about selling Markforged printers. And as the relationship grew and I started to do more research into this company, I eventually came over to America and actually did some training and ended up very happily now working in part of the team here. And another thing we're very happy to sort of talk about today. It's a very good day because we've literally today launched the first micro factory outside of the US and in fact worldwide. And that's starting pretty much today. We've got Kent Gilson, our founder and inventor, and Mike Phillips, VP of Sales, actually in Australia now, setting up the first microfactory in Toowoomba, of all places. You'll hear a little bit more about that in this presentation. And also, you know, I've also been busy setting up the first part of our reseller system, a reseller network. Both the resellers I have engaged, or we have engaged at Haddington Dynamics, are both Markforged dealers as well. SF Design, my good friends at SF Design based in Perth, they look after sales and distribution for our brand in the Australia and New Zealand market. And we also shout out to my friends at Chemtron in Singapore, who at the moment are our representatives of Southeast Asia. So a little bit about Haddington Dynamics. I mentioned a minute ago about Kent Gilson, who is our super genius brain box, has come up with the pretty innovative design of a robot based on first principles design. This is not derivative at all, and I'll tell you about some of the special features about the Dexter platform in a moment. But it's based, as Richard said, in Las Vegas, where we are now, and launching this. In 2015, the company really actually set up properly in Kent's garage, in typical sort of startup Silicon Valley style. And it wasn't long until the 2017 successful Kickstarter was launched, which was successful. That resulted in us being able to ship the first Dexter units in kit form. And that then that development evolution resulted in us winning the 2018 Hackaday Prize. And it was described as an absolutely unique development in the robotics field. We've also, up to the stage, entertained many clients. Our biggest cheerleader would have to be NASA. And in fact, NASA was the client introduced us to Markforged. They brought some parts along and persuaded us to invest. I'll tell that story a bit further on. But we've also obviously worked with the Toshiba, DuPont, and certain research labs like the Toyota Research Institute and MIT, where one of our senior programmers is actually based. So what does Haddington Dynamics do? Haddington Dynamics has invented and has just started distributing the world's first robot with native touch and feel. And I'll get to that a little bit later. But essentially, if we're comparing it to robots that are out there in the field at the moment, this is a 7-axis robot. Potentially further axes are possible within our system. It has a 3-kilogram payload at the moment, but you know, this is a scalable thing. We have over 200 3D printed parts, part of our assembly, and these are all obviously made by the Markforged 3D printers, both just the plain Onyx and with the carbon fiber filament as well, CFF, placement of a few key strategic parts. The secret, the Colonel Sanders secret spices for Haddington Dynamics is the FPGA boards that we use, the chipsets, the field programmable gate arrays. And Kent Gilson, the founder I mentioned earlier, is really one of the fathers of this world. He pioneered a lot of the supercomputer programming for the FPGA chipsets, and then actually wrote his own language with these chipsets. So we're able to program the whole robot by the onboard computer, which sets it apart from any other robot in this field. Those robots tend to have a massive controller attached to them at a bigger expense. And what's really, really interesting is, so Kent tells me, we're only using 20% of the capacity at the moment for our FPGA. So there's headroom there for vision systems and things of that nature, which I'll talk a bit more about in a moment. And one of the great things is unlimited end effector options. Not only can we integrate third-party attachments, but we can iterate really quickly our own attachments and end effectors for fit for purpose via the Markforged 3D printing system. And as I mentioned before, one of the key features of Dexter is this better than human touch sensitivity, our torque feedback from our 3D printed encoders, 3D printed on the Markforged obviously, with the cheap availability of the FPGA processing power that we have on board. We can calculate over 1 million positions per revolution of each 3D printed encode disk. Now this, without going into too much detail, really gives us the edge over anything similar in the market, and it provides the mechanism to derive that torque feedback out of our system. So what are collaborative robots? CoBots is a term you're going to be hearing more and more about. Now, what a CoBot basically is, as distinguished from a robot in a traditional sense, is CoBots are designed to work alongside and with people. Yeah, typically a robot. This new form of robotics, CoBots, have been also referred to as power and force limiting robots. So basically, if a human is working alongside one of these robots and has touches the robot, or in any way touches it in a way that could possibly be injurious to the person, the robot will go back into a home position or walk away or get away from the human in many other ways. Now, the first CoBot was only really implemented in a commercial sense only in 2008. So they're only literally over 12 years in a market, but it represents the fastest growing robot sector at the moment, with over 300% growth in the overall robot percentage per year. Now that also, if you compare it to traditional robots, which have actually seen a slight decline, we can see that there is an undying requirement for these robots which can increase productivity of people, not taking away people's jobs, taking the dull, dirty and dangerous jobs. Now there is an evolution of these cobots, and at the moment, if you can see the graphic I've put there on the mother, most of the robots either work in, or cobots work in, the coexistence or sequential collaboration, not directly working with the humans. We feel that our Dexter program is pushing the field of cobots to the next level, where we not only have cooperation, but the responsive collaboration, which is the ultimate aim of the CoBot markets. Nothing commercially is really able to do that fully collaborative interaction with humans right now, except for Dexter. So we do have that, the ability to be able to work alongside humans with what we call our physical human user interface. And it's a pretty mind-blowing thing. I'll go to the next stage. So we talked about the 3D print farms as an integral part of the way we see our robots going forward. I mentioned earlier on, we are right now installing the first microfactory in Toowoomba, Queensland, which is being installed at Decisive. But the ultimate aim is not just to use the 3D printers. Anthony, I think, is going to explain fully another good reason why we use robots instead of injection molding, for example. But we're able to presently, with our fleet of 13 Markforged desktops, produce around 30 robots a month. And so clearly, the organic way that we can scale this is really the benefit. Rather than having to tool up for injection molding with minimum order quantities, we can scale and just simply buy more desktop Markforged printers, which I think Richard will be happy about to hear, to scale to build more robots. And that's what we're looking to do. At some stage, we are looking to scale this to build hundreds, maybe if not thousands of robots, hopefully distributed across our network, across the world. And in Australia, we'll be the first of many. Now, it's not just about throwing a few prints into the print farm. What's really, really interesting about the idea of a 3D print farm, and we've been thinking about this a lot for a while, is the organization structure that goes behind it. Essentially, to do this properly, you need a form of ERP system, if you like. We start with our digital twin in Autodesk Fusion 360, and that allows us to sort of iterate quickly. If we have changes in the design or updates to the design, we can update the BOM and have that new part ready for the next run on the 3D print farm for the next robots. So there's no minimum order quantity again. There is simply a series of build plates that we put into the print farm, with each individual Dexter requiring around about 300 hours printing to complete the BOM. But what we have, though, is essentially, and this goes back to what I've been evangelizing for a while about the 3D print farms, is the need to have the digital warehouse. Richard also sort of alluded to that is the way of the future. So rather than having warehousing of parts, we don't need to do that. We essentially make our parts before, well, it's sort of the fast tracking time system of producing the parts on demand for the robots that we have on order. And as that expands, we will so expand the BOM list. Also, again, it might be mentioned that we do also support STEM programs, and the STEM programs will be utilizing the same sort of BOM within their curriculum as well. We will be developing a curriculum based on the Unity platform, and that'll be coming soon. So what do we do? How does it look in our 3D print farm? Well, it typically starts with our Dexter digital twin in Fusion 360, and I do know that in the audience out there is SolidWorks dealers, and I apologize, but simply a CAD program, if I could say it in that direction, is the first place to start. So having that digital twin, being able to also, within some of these systems, run some stress analysis as well, also helps, especially when we get then to then doing the parts. As you can see here, I have Eiger up on the screen here with some CFF placement of a strategic part. Typically, we put the carbon fiber filament in differentials and gears and things of that nature, which have that stress loading, and the rest is simply Onyx. But back to the point of why we have a 3D print farm, it is cost prohibitive for us to injection mold all our 235 parts. We did cost about $7 million to buy all those tools and then have an MOQ and then have a warehousing. So what we're able to do, and we have produced over 300 robots to date and delivered them, but what we have found is that we're able to iterate new design changes really, really quickly. And that is a key part of our 3D print farm. So the new design is also the new end effectors. And what do you do with that robot? Well, normally end effectors can sometimes be more expensive than the robots. And we're looking at, for example, a universal robot, UR3, it couldn't be anything around $27,000. A end effector, suction-based pick-and-place end effector could literally be another $27,000. However, within our system, we're looking at like $11,000 for a fully built Dexter. And then if you have a Markforged 3D printer, you can iterate new designs for end effectors really, really cost effectively and to fit for purpose, designed exactly to pick up or place your parts or to do your inspections, to hold those scanners, the myriad of different things that robots can do. And also, obviously, easy scaling and production. And once again, making Richard happy. The way that we would have to produce more robots is simply to buy more printers and to scale that. And that also applies to the micro factories, which we will be placing all around the world. Obviously, the first one in Australia, they're starting with, I think, about half a dozen 3D printers. And as the demand grows, as the orders grow, simply buy more printers. And rapid adaptability. The other thing that we get involved with is what we call NRE, non-recurring engineering. And that is building a specific design, not just with the Dexter arm, but essentially involving a whole control system, an FPGA system. We are presently just about to sign a deal for I can't say too much about it, but it involves automation of food preparation. And that rapid adaptability within our 3D print system, as opposed to injection molding or tooling and more traditional methods of manufacturing, that means that we can rapidly scope and deliver to our clients faster than anyone really can do in our sort of marketplace right now. So that rapid adaptability, which we get through the 3D printer farm and the Markforged, really gives us a distinct advantage in the marketplace for this area. So going forward, what do we want to do? These are probably closer to our wish list of things we want to do. Now, our founder, resident Brainbox Kent, has coined the term heterogeneous direct digital manufacturing. And that is something that we are looking to expand within our workplace here. What you can see there in the picture above the cycloidal is a cycloidal drive. And that was something that we built internally on the Markforged 3D printers. This was in response to us having a little challenge trying to get the harmonic drives that run our machines. And we did talk about this in the Markforged video. Now, what heterogeneous direct digital manufacturing essentially is embedding parts, making a totally encapsulated part on the 3D printing by utilizing the pause at height function. Our heterogeneous direct digital design cycloidal drives required us to stop the 3D printer over 5 times to encapsulate different bearings within that process and to restart it. Now clearly that is a challenge when bringing in humans someone has to be there at 2 in the morning when the thing stops to place the bearing, and certainly that is a challenge. But it also gives us the reason to pursue our dream of automating our 3D print farm with our own Dexter robots, which, as you can see, we have started that process. But not only are the robots then designed to just take parts off the 3D printer, which they can do, but to also stop the 3D printer, place those bearings, nuts, differentials, whatever, within the print and to restart it so that they actually come as a fully encapsulated part. And that is where we want to go with the next stage of our 3D print farm. And also, using our robots, we intend to automate our internal processes. And these internal processes are going to help us to create a more productive workplace, but also they can become products within themselves. The first one being is our wiring loom system that we have actually started. That's a little bit of mock-up there with my Dexter on the board there, pulling a bit of a wire, but that is the direction that we will be going, and many more automation projects within our assembly system are going to be highlighted. So coming to the end of this, the future, what does the future represent for Haddington Dynamics in terms of the 3D print farms? So we anticipate, and we have potentially got somebody looking to fund this. Somebody is looking for a larger payload Dexter, utilizing our control systems. So to do that, obviously we've pushed the Onyx to, what we think is a maximum of maybe the 3 to 5 kilogram payload. But to go beyond that, to go to the 20 to 30 to 50 kilogram payload, clearly we're going to be dealing with greater stress loads. Clearly we're going to be dealing with larger scale units. And so, the process, what we're looking at is to incorporate generative design. We do, and I will have to say, we do have a relationship with Autodesk. But for the SolidWorks guys out there and all the other guys doing different analysis, topological optimization, or generative design, to use to actually apply the FEA to our upcoming models with the bigger payloads to determine how we can create that lowest payload possible for the robot itself to increase our payload for what it's picking up. And to do that, we would have to then go to the next stage of 3D printing, which would incorporate using the Metal X and obviously the new Sinter 2, which gives us that larger build volume to be able to build those correct sort of systems. So we are looking at that being the next stage. Titanium, maybe also using some of the new copper for some of the internal wiring as well, shielding. That's certainly the next stage. We're looking to do that. And really, when we're looking at these robots, we are looking at low to mid volume. We're not going to be able to straight away make 1,000 of these like some of our bigger competitors. So the 3D printing, the metal 3D printing will be the perfect solution for that. We intend to do that. And finally, one of our other aims is to produce the shipping container, micro factory, 3D print farm in a shipping container, deployable. We know that personally, I've been involved with defense contracts that have been looking for this solution to deploy, looking at having its own power source, its own air conditioning. But it's not just about having a bunch of 3D printers and outputting it. The heterogeneous direct digital manufacturing, the ability to be able to do light assembly work, sub-assemblies, to be able to do that sort of work in the field on demand is something that does have a huge demand, and that's certainly going to be one of the areas that you'll see us going in the future. Lastly, a little bit of plugging. If someone did want to get more involved and look at our robot system, we have what we call our Maycations, and they're held in happy Las Vegas, where we are right now. And you come along. Ben from Decisive came along a little while ago. Recently, we've had Matt Staples from SF Design come. The guys from Singapore have all done their own training as well. But we encourage you to make an inquiry, give me a call, come to Vegas, and we'll look after you. And make a robot. Essentially, it costs about the same to buy a robot as to come here and make one. It's more fun making them. And that's it from me. So if anyone has any questions, I'm happy to take them.
Cool. Thank you, Jason. What we're going to do is we're going to hand over to Anthony. So if you stop share screening, and we'll get Anthony Rosengren to talk about real customer examples from the industry. If you have questions in the meanwhile, please use the Q&A button on your Zoom screen, and you can start typing in your questions. And after Anthony's presentation, we will answer all of your questions. So Anthony, over to yourself, mate.
Thanks, Richard, and thanks, Jason. So before I begin, I'd just like to quickly introduce myself. I work directly for New Zealand and India. I've got a background in engineering and design, and it's really great to see applications that are coming out of the APAC region and America. Okay, so how can 3D printing benefit startups? So we've seen one example, and basically 3D printing lets you rethink how things are created. So you may think, when you have a startup, you use injection molding, you use machining, you use these established techniques, but we are introducing another established technique. So I will talk about the current trend in using additive for making end-use parts and how continuous fiber filament is enabling this trend. I'll then go on to chat about how additive can benefit startups. I'll discuss how hardware startups traditionally function and make a comparison of the role that Markforged technology can play in accelerating this growth. Consumer 3D printing. So despite the hype in the last 10 years, plastic printing, i.e. PLA, ABS, resins, straight nylon, presents a lot of barriers when creating marketable end-use parts. You'll typically come across problems with surface finish, the effects of weather over time, repeatability, and general durability of the part. You can't base a startup on low yield technology that produces parts that aren't going to last. So what we offer is continuous filament fabrication, and which is the Markforged process that lays down continuous strands of high-strength composite fibers like carbon fiber, fiberglass, or Kevlar in a Markforged matrix material that we call Onyx. So this process creates parts that have a better strength to weight ratio than 6061 aluminium and has a repeatability of within 10 microns. So in terms of Haddington Dynamics, a lot of control over the weight of your part, which in robotics is extremely important in terms of reducing the moment of inertia and the agility of your robot. So here is a cross-section of a continuous fiber filament part as shown in our software, IGA. So this shows the hollow infill possible with additive manufacturing. The white lines present the plastic matrix material, which is Onyx, while the yellow lines represent the continuous strands of fiber, which is, in this example, Kevlar, that will be laid in the part. And here is that layer as it is printing. So keep in mind that you won't see this in the final part. You won't see the fiber. So this will be fully encased in our material Onyx. The continuous fibers will allow tremendous strength and distribution of energy within the parts. Parts, or how are end-use parts already helping to grow ANZ businesses? As an applications engineer, here are some of the applications that I've noticed coming out of Australia and New Zealand. Some of the industries are agriculture, with end-use parts being implemented in field and used in paddocks, which I'll go through later. Drones, we're finding that with drone startups, Onyx with continuous fiber produces great parts that are lightweight and durable. Product design, so whether you're designing products and producing products with end-use parts or printing molds, there are a lot of different ways that Markforged is being engaged in product design. Construction equipment. When you have small parts, we have a couple of businesses who are producing small parts that are not easily able to be made for their equipment that actually goes on construction sites. Robotics, which is self-evident with Haddington Dynamics, and motorsport, custom parts used to create end-use parts, or printing directly printing custom parts. We're seeing this trend in terms of applying this technology to motorsport. So when you're a hardware startup, there are a couple of options for making a product. There's molding, machining, and now finally 3D printing end-use parts. A mold can cost between $30,000 and $100,000 with a 3 to 4 month lead time and is quite labor intensive. Whereas if you compare that to directly printing a Markforged 3D printed part, the cost will be in the hundreds of dollars with a 1 to 2 day lead time and minimal labor. So just so you have an idea for a hardware startup, how do you make this happen? So traditionally, you need to have that part designed. That can be in-house or outsourced. That will cost time and money. The mold needs to be designed. Generally, if you're a startup, you won't have in-house design expertise for molds. So that generally needs to be outsourced, which will also cost time and money. You then need to go to a mold maker, which costs further time and money. Go to an injection molding facility, which costs even more resources. So in terms of spending this, in terms of time can be taken up with shipping, communication, and costs can be in waiting for things to happen, wages, checking mistakes, waiting for public holidays in other countries. All of these things contribute to this. With Markforged, there are less steps in this process. You design and slice the part. That costs some time in terms of, and money in terms of the design you're putting in. You print and then you sell your part. I've got a little moon there, which sort of indicates lights out manufacturing. So that's the idea of pressing print before you go home, coming back to the office, and then you have your parts. One of the key things I want to mention here is the iteration. So with the traditional manufacturing, the first 4 steps are very difficult to iterate because there is a lot of cost involved. Whereas with the Markforged method, iteration is much easier. Okay, so with these 2 graphs, the red line represents amount invested and the green line represents the amount earned. On the left, you can see how your money will flow over time with traditional techniques. When run out quickly with limited chances to iterate. It's roughly 9K for a small injection mold. And there is usually a minimum run of parts with the mold. So even if you make a small batch of 100, there's potential to make mistakes and then having to go back and fix those mistakes. Traditional methods will have a higher business risk because until you have a perfect product with the proven value in the market, there is nothing to show for the investment that you've made. With end-use parts and 3D printed end-use parts, iteration and the ability to use your printer flexibly lowers business risk. So the chart on the right shows that with Markforged, you can start selling immediately and produce your product on demand, leading to profitability sooner. With Markforged, you can also do small-scale injection molding using hand press or using pneumatic pressure techniques. So the chart on the right, so the white line will represent the capital cost of the Markforged printer. The orange line represents the Markforged total investment as you buy materials. And the blue line represents the savings compared to traditional methods. So this ROI can be achieved within 3 to 4 weeks with additive manufacturing. Let's have a look at another example of how 3D printed end-use parts can enable startups. Livestock Labs is a 2-year-old startup with 7 employees based in Sydney. Their product, Embedivet, reduces the need for costly herd-wide inspections and treatments. Their particular challenge was to create a product in a way that made the most of seed funding and allowed iteration of the designs, when all parts had to be strong, have a great surface finish, and be resistant to weather. The savings that were realized by using Markforged's Onyx technology over alternatives such as CNC machining and injection molding, which would have cost around $40,000, enabled Livestock Labs to develop their products by printing molds and end-use parts. So the other savings was in time, as the prints had a fast turnaround of hours, whereas CNC machining would have taken days and injection molding months. So as Jason has already talked about, the second case is in Haddington Dynamics. So Jason mentioned that they have approximately 200 3D printed parts, or over 200 3D printed parts on each Dexter, including 20 with continuous fiber filament, so including 20 with continuous carbon fiber inside these parts. So just to tool these 200 parts for injection molding would have cost around $7 million. And they would have had to maintain an MOQ of 1,000. And they couldn't iterate with new updates without huge costs. So now I'd like to hand back to Richard to finish off.
Sure. Thank you, Anthony, for a great presentation. So where I wanted to take things from here, right, is that it's been really informative to to learn from you guys in terms of Haddington Dynamics and Markforged. So where do you all on the call? Where do you go from here, right? So I'm sure you have lots of questions. Please start typing the questions into the Q&A. I can see the questions coming in, but I would encourage you as well, go check out the design for additive manufacturing guide. So we have one for composites, we have one for metal that you can find on Markforged website. We also have lots of these type of webinars, both on our website and on our YouTube channel, that you can learn a lot more about Markforged and how to design for additive manufacturing and for robotics. I would also encourage you to look at different options at our Eiger software. So Eiger is our free-to-use 3D slicing software. So if you go to markforged.com, or you can just Google Markforged Eiger, you can sign up for a free account today, upload your files, and see exactly what is the print time, what is the material cost to make these parts, right? So that's a good way to start. And of course, we have value-added resellers all around the world that have Markforged equipment in whatever city that you live in. So of course, anyone that's on the webinar today can organize a free consultation with the specialist in your city and get a free demonstration of the Markforged equipment, or show you some robotic parts that have been 3D printed from Haddington or from another robot manufacturer. So at this stage, I'd like to open up for some Q&A. Maybe there's some good questions coming in here for for Jason and for Anthony or myself. So please start typing things into the Q&A, right? So we have a question here. Maybe Jason, you can unmute yourself here. There's a as a customer, maybe you can answer this. So there's a question from Clive here. In Australia, Jason, what do you see as the biggest barriers to adoption of 3D printing for finished parts production?
Yeah, I'm glad you asked me this, Richard. As you know, we've probably discussed this quite the same subject quite a lot. I mean, I think really what the barrier really is that it's a difficult environment in Australia to take huge risks, and so to change your method of production of an existing part, to change the method of assembly or anything to do with that is a pretty big task. So I just think that the holdback in Australia is really about just the funding. In a place where in America here we've got 300 million people, you can scale things and you can hit that sort of economical barrier that allows you to invest in new processes. However, I think in Australia, and I've worked in that area for a very long time, as you know, Richard, we have some of the most innovative guys in the world to figure this stuff out. We just need their bosses to sign off on the purchase orders to make this stuff happen. Really, I've seen so many situations where end-use parts from a Markforged specifically can really add value to automotive, to mining operations, so many different things. It just needs someone to sign a PO.
Mm-hmm. Yeah, that's a good answer. Hey, there's another question here, maybe for Anthony from Khasra, which is, what's the smallest size you can print, Anthony?
So we have a design guide freely available online, or you can ask our local resellers for the design guide, which will give you detailed information. But our layer height is basically 50 microns. So in theory, you could just print one layer, which is 50 microns thick. So it's you can get quite small. Resin printing will enable things like jewelry, but in terms of our technology for in terms of the layer by layer height. 50 microns in the Z direction is the smallest, and the XY is depending on geometry and the nozzle diameter.
Fantastic. There's a question here from someone asking about these kind of like robot end effectors, right? So Anthony, what would be the benefit of like at the moment they're machining these in aluminium? So why would they consider 3D printing these?
So there's a couple of reasons. The main reason is with a robot, the moment of inertia is extremely important, i.e. how heavy is the end effector. As you move along the arm, the consequence of being able to move the robot increases with that weight. So to reduce weight is a massive reason to use continuous fiber filament, and also to design the parts so that you own, which is much easier than machining that part. So basically design freedom and reducing weight with the same stiffness and strength as aluminium.
Absolutely. Yeah, that's a good question. So there's a question here for you, Jason, from Rajesh, which is about the Haddington Dynamics. Do they need any safety certifications, or do the customer have to certify these, or is there any limitations around certifications to use these?
Yeah, no, that's a good question. Listen, there is an ISO that has been developed for CoBots, and we're in the process of actually going through that, through the process of getting certification for that. But in a lot of cases, it's around the specific purpose for that robot. So certainly the certifications for medical, for food, and many things. So we are in the process of looking at those certifications for certain projects. But I will mention that in terms of like electrical certification, our power usage is so low, it's less than 100
we
watts.
qualify as a computer peripheral more than a robot.
I have my colleague here, Todd
Sorry
Edison.
about that.
And,
no, we qualify more as a computer peripheral than a robot because we're under 3 amps of power.
So in terms of the power solution, that is certainly the solution around that. But yeah, I think what I would ask if someone wants to know about certifications is what industry. We have such a wide base of industries that really we need a more targeted sort of certification around that.
Makes sense. Here's a question, I guess. I mean, we've shown some pictures from Chris, which is about do you have any examples of the surface finish of the Onyx material, right? So Chris is probably thinking of like other 3D printers and what they're spitting out. Like, can the surface finish really be compared to injection molding? So, Jason, Anthony, I'm not sure if you want to answer, and maybe we can send some pictures to Chris as well.
Oh, listen, I'm happy to jump in and answer that. I've been using Markforged for 5 years now. Now, what you really see with the Onyx is I think that's one of the biggest revolutions of the Markforged printer. What you'll see, and if you're typically used to 3D printing, maybe from PLA or ABS printers, you see those lines, the layer heights are clearly delineated. What you find with the Onyx is that you do not see that layered surface with this. It seems to somehow, the magic of Onyx seems to sort of all spread out. And that really is a big key part to what we do. We ship our robots with a fully assembled skin made of Onyx, and people love it. I mean, it's got that glow as well. So yeah, is it comparable to injection molding? Not directly, but it's absolutely near as damn fine as far as you get with 3D printing with an FDM printer.
Then we've got time for a couple of more. Then there's a question from Victoriano here, which is about that we saw some gears there on some of the slides, right? I mean, can the printer really make these? And like, is this a good way of making these gears, or does that affect the precision of the arm?
No, what's really amazing about Markforged is we're able to obviously put the CFF into those gears to increase the the actual strength of them, especially in the areas that are differential. Now, we've run these robots now for thousands and thousands of hours with the same Onyx parts printed. Also, I mean, part of that is due to the unique nature of our robot. Our robot has force adaptability or force variability, and so it's able to adjust itself on the fly. So if the gears start wearing, the robot will adjust itself to compensate for that wear. And plus, you know, there is no other way other than getting these machines on the CNC for us to use. So absolutely, it's fit for purpose. The gears work beautifully. And also, you know, we just recently implemented a new split gear system. Now, if that was a normal tooling shop, that would have taken months to do. We literally did that in a couple of days. And actually, Todd has something.
What we've noticed also, and we did some testing with this, is we 3D printed a worm gear, and then we watched the wear. And so what you have is you got the Onyx material, and then the CF, continuous CF underneath it. And as it wears, there can be some wear on the Onyx, but as soon as that carbon fiber meets carbon fiber, the wear stops, and then you almost get this self-lubricating because you got this carbon on carbon, which was it's that burnishing technique that you get to a point and then the wear stops and it works fabulous.
It is actually. We should mention that it's when we wear the robots in with, you know, a couple of 100 hours. Initially, it actually gets better. If you look at the printed Onyx under a microscope, you'll see these tiny little tendrils, which are basically the chopped carbon fiber just sticking out. And so after a few hours of wear, a couple of, 20, 30, 100 hours of wear on the gears, all those little tendrils get worn down to nubs. And so it actually becomes a smoother surface. So really, yeah, it's a perfect substrate to use for gears and differentials.
Just a quick question here from Akshara here for Anthony. 3D printed parts. Akshara is skeptical to the strength of these, right, compared to machine parts or a mold part. So anything you can share there, Anthony, in terms of details around the strength of these parts?
Sure. So if you're casting metal, then you have the molecules aligned in a certain way, and that'll give you great strength. And you can do FEA analysis, and there are data sheets on that, which is great. One way you can begin to compare is that with our continuous fiber, that is pure carbon fiber. So that you can see the strength of that through our data sheets, and that will hold up as we describe it in the data sheet. When you combine that with the Onyx, that's sort of like concrete with steel in it. So you can put the fiber in the tensile areas and the Onyx in the compressive areas. So because it is a composite, in terms of doing a direct comparison, it is difficult to do sort of FEA analysis or compare without actually printing the part. So we recommend doing a benchmark part with some design for additive manufacturing, so that you can test these parts yourself and do that direct comparison. And that's the way to know for sure.
Cool. And then a question here from Daryl to you, Jason. So some images show, Dexters Feet, some show a rail system, some show various types of movements. I mean, can these robots be customized, or what's the go to, what's the options here?
Yeah, absolutely. That's a really good question, in fact. So I'll start with the actual control system. So the control system, the FPGA control system that we utilize, designed by Kent, is controlling all of the 6-7 axes on each of the robots in parallel. We actually have capacity to put like over 100 axes if we wanted to. So as we maybe employ a rail system or some sort of mobile system, we can simply use add another axis into our system to be able to control those. So what we have done though is you may have seen that rail system that we employed for the 3D print farm. We actually printed on Onyx an internal linear system to actually be able to motivate those robots. So we actually
slides right into the 80. It slides right into the 80-20. So we get in one build plate, we get 2 meters of linear rail gears.
Yeah, so we got the gears to help them motivate those positions, which makes it really, really scalable and easy. And in fact, inverting the robots is one of the things that we are finding helps for a lot of situations. The other thing that you mentioned, so the 6-foot arrangement, that's our standard arrangement, and that comes standard. But again, it's modular. That simply slips off and can be adapted to another thing. But that also can be a housing for battery power. Because of our low power usage, we can actually turn that base into a battery unit for remote stuff, and solar power the thing as well. So it's the whole point of having a 3D print farm is that we can change things rapidly. So we're in fact, there's one more thing you might have seen. Boston Dynamics Spot, the dog, looks like we're going to be actually putting one of our Dexters on those dogs. So that'll be interesting. So that'll be I'm looking forward to that one. But yeah, we're pretty scalable.
So just we've got 2 minutes left. So just a minute from you, Anthony, and then last minute from Jason. So, why is the future of additive manufacturing happening right now? And how is, manufacturing changing today in the world, thanks to robotics and 3D printing? So, Anthony, do you want to share for a minute, and then for Jason to just finish off today?
Okay. So in terms of why is it happening right now? We're basically getting a confluence of events in terms of the technology and economics. So we have finally got to the stage where we have reliable machines producing high resolution. So this technology is now mature, and which is enabling this to happen. The second thing is that education is getting better. So when CNC machines came out, people needed to be educated into how to learn how to use CNC machines to create products. And the same thing is happening with manufacturing and with additive manufacturing. And the third thing is that with the economics of things, additive manufacturing enables things to be produced locally. And this is as the price of producing things overseas gradually increases. Eventually there'll be an inflection point where things will come back to local manufacturing. So there's a few reasons why this is happening right now.
Cool. And last word to you, Jason. Take it away.
Yeah, listen, I think I agree with everything Anthony said. And, what I'm seeing, and especially actually in the smaller markets like Australia, is there's a massive barrier to entry to actually manufacturing something. And that barrier to entry is the tooling costs. We mentioned it again. Now, most people in their assembly, if you ask them, especially in places like Australia, you ask them, well, how many of these parts do you need? You order 1,000 and you warehouse them, but how many do you need a month? And if the answer is I need 20, 30, 40, 50 a month, then those are the numbers that work for 3D printing and 3D print farms. And I think you'll find there's a huge amount of that low to medium volume manufacturing and bespoke manufacturing that's growing. People are realizing they can get stuff that doesn't have to be mass produced. And in fact, the reshoring opportunities out of that are very, very important to markets like Australia. So I think for the future of manufacturing, things like microfactories and 3D print farms and being able to iterate quickly, do medium to low volume, all of those things mean that this is a really, really vital part of the economy going forward.
Thank you so much, Jason and Haddington Dynamics. Thank you, Anthony, for joining, and thank you all customers. We'll be in touch, and feel free to contact us for any questions. Thank you.